So this is one of those kind of cookie cutter math things. If you follow these steps, then should be good to go on these. So excluded values is something that you want to take care of first. I've taught myself to do this first because if I don't do it at the beginning, I'll forget to go back and do it at the end. These are going to be linked to extraneous solutions. So those two parts kind of go together. We're not going to see that in the first example, but we'll talk more about it when we get to the second example. I've always called it fraction busting, where you multiply strategically on both sides of an equation so that your next step doesn't have any fractions anymore. Is that what you guys called it too? Maybe not. Okay, that's fine. This bust fractions means get rid of your fractions. We'll solve the equation, and then sometimes we'll have to go back and check for extraneous solutions. So an extraneous solution is an answer that we get by following the rules, but it doesn't work in the original equation. Okay, and there's a variety of reasons that those can come up, mostly revolving around things that have restricted domains like fractions and radicals. We won't see radicals today, though. So let's do it. First example here. I'm going to copy this over so I can make it a little bit bigger. 2x plus 11 over 7 plus x plus 9 over 7 equals 5 over 7. So step one is to look for excluded values. Excluded values would be values of x that cannot go into this equation. Okay? And I'm not talking about go into it and make it true. I just mean like they absolutely cannot go in there. And I would say there are none because I don't see any fractions that could potentially end up with a 0 on the bottom. I don't see any radicals that could potentially have a negative inside. So there are no excluded values for this equation. Another way to say that would be if I were to look at both sides of this, the domain of both sides, the domain of both sides would be all real numbers. There's nothing that I'm not allowed to, there's no real number that I can't put into this equation. If that's not making much sense to you, wait for the second example. We're going to see excluded values there. So to solve this, we just need to bust the fractions. We need to come up with some strategic thing that we can multiply both sides of our equation by so that there's no more fractions. What do you suppose that thing is for this one? 7, right? Because if I multiply this fraction by 7, it's just going to be 2x plus 11. If I multiply this fraction by 7, it's going to be x plus 9. And that fraction times 7 is just 5. And that's a nice simple algebra 1 equation that you all know how to solve. So go ahead and finish that up. All right, we feeling okay so far? Before we go on, I want to talk about a skill that we can use to check our solutions here. It's also just a useful skill in general for when you're trying to solve equations and you don't really care about getting an exact answer, but we'll need our calculators for this. So if you don't have your calculator out, go ahead and pull it out. So over here, I'm going to solve using calculator. If we want to solve an equation using a calculator, and by the way, this works for any equation. We will be using this pretty extensively when we get to trigonometric equations in chapter 4, chapter 5, I can't remember. So I want to introduce this to you now because it'll be useful for checking, like I said, but we're also going to use it again later. Just a couple quick steps. Step one is to take your equation and get a 0 on one side. So do whatever you got to do to get a 0 on one side of your equation. So I would probably subtract 5 over 7 from both sides. So my new equation would be 2x plus 11 over 7, x plus 9 over 7 still, but we'd have minus 5 over 7, and then this thing would be equal to 0. And then what we can do now is we can think of this side of the equation as a function. And we can find the zeros for it, because the zeros of this function are the things that would make this thing equal to 0. And that would make the equation true, right? That's what zeros are. So what we're going to do is find zeros of this function. We'll do this in the calculator. So we'll be using the graph to do this. So go to y equals, and we're just going to type in that side of the equation, the one that's not equal to 0. Be careful with your parentheses. We're going to graph this, and we're going to find the zeros. Where are we looking on the graph to find zeros? For any function ever, where do you see zeros on a graph? On the x-axis. So I don't really care what the shape of the graph is. I'm just looking for where it crosses the x-axis. Well, we've already solved this. We got one solution, so I'm anticipating that we're only going to see one solution. Oh, look, there it is. Okay, we knew it was -5, but let me show you how we could use the calculator to get an answer, and then we're going to do this on the next one too. So we're going to go to second calc 0. This is what you use to find x-intercepts or zeros for a function, and it's that whole left-bound, right-bound guess thing. So we know what we're going to get, but let's just practice going through the motions here. So move your cursor using the arrows a little bit to the left of that x-intercept, hit enter. Move a little bit to the right of that x-intercept, hit enter. Put it kind of close to that x-intercept, hit enter, and it should give you that 0 at -5, 0. All right, so any questions? Okay, let's keep going. All right, so we'll go through the same process on this, the same 4 steps. Excluded values is what we're going to start with. Again, I kind of wish we'd made these equations bigger. I'm going to copy my equation over. I'm going to leave some space between my fractions. All right, do you know solutions to this thing? I can't tell solutions to it, but I can tell you something about the solutions. I can tell you 2 numbers that are definitely not solutions to this equation. What 2 numbers absolutely cannot be solutions to this equation because they can't even get plugged into this equation without breaking a major rule? Say again. -2 would be a problem because we'd end up having 1 over 0. What's the other number that cannot go into this equation? 0. So our excluded values would be those 2 things. When we say excluded values, we're looking for things that absolutely cannot go into the equation no matter what. And if they can't go into the equation, then they certainly can't be solutions. So our excluded values would be 0 and -2. So we're going to solve our equation, and if either of those pop up as one of the solutions that we get from doing our algebra, we have to throw it out. That would be those extraneous solutions. All right, so I do this first because if I don't do it at the beginning and write it down, most of the time I forget to do it at the end. Okay. All right, so let's decide what we're going to be multiplying both sides of our equation by this time. Something strategic that is going to cancel out both an x and an x plus 2. What do you guys think? Ideas? How about x and x plus 2? Yeah. If I multiply this fraction by both x and x plus 2, that would cancel that x out, wouldn't it? We're still going to have the x plus 2, but at least we won't have a fraction anymore. If I multiply this one times x plus 2, the x plus 2's would cancel. We'd still have this x, but at least we wouldn't have a fraction anymore. This 5 didn't have a fraction that we had to worry about, but the rule says if we're going to multiply, we got to multiply everything by the same thing. So, all right. So if we do that, then we can start canceling stuff. Those x's are going to go away. This x plus 2 is going to cancel with that. And yeah, we got a bunch of stuff left over. I'm going to copy down everything here. I found that if I skip this step, there's some mistakes that I tend to make. So I don't skip it anymore. I don't need anything else. That's it. It's just 1x, isn't it? All right, no more fractions. Go ahead and solve that. Folks, can you look at that equation and see that that's going to end up being a quadratic once we get rid of our parentheses? Do you see there is going to be an x squared in this thing? Yes? There's going to be an x squared over here. So how are we going to solve something that's a quadratic? You get a 0 on one side, and then you've got multiple options. Maybe we'll be able to factor it, hopefully. If not, quadratic formula or completing the square. So go ahead and do it. You don't need to copy my work down for this. This is now an Algebra 1 level problem. Get rid of your parentheses, combine like terms, and then get a 0 on one side so that you can use your quadratic tools. Don't copy my work. Do your own. Oops. I don't think that factors. Is anybody able to get that to factor? I don't think it does. Cool! That means we can use quadratic formula. Yay! Or completing the square. Completing the square is kind of a pain when there's a coefficient in front of the x squared. I think I'll do it with quadratic formula for this one. X equals opposite of b plus or minus the square root b squared minus 4ac see. All over today. Uh, 20. That's 120. 36 is 156. 56, 78. Bless you. How are we doing? How am I doing? Did I make any mistakes? Oh, I see some quizzical looks. I better check my math here. 6 squared minus 4 minus 5 times negative 6 is 156. Divided by 4 is 39. So 2 root 39. No, I'm pretty confident. I don't know. We'll find out in a moment. I typed both the plus and the minus version into my calculator a moment ago to get some decimals because I'm going to check this by using, sorry. So I just typed both of those answers in. I'm going to check my answer by using the second calc zeros thing and see. If I get answers that are pretty close to this, then I'll be feeling pretty confident that that's correct. Any questions before we do that? Yes? Follow instructions. I'll probably ask for, so the question was this or this. Follow instructions, but I will probably ask for exact values on the test. But if I ask you to round it, do it. The only reason I put this here is because when I use the zeros thing, it's going to give me a decimal. So I want to be able to match it up with that. Good question. Thank you. Any other questions before we check this thing? So we need to make this equation here have a 0 on one side. That would be 3 over x plus 1 over x plus 2 minus 5 equals 0. So we'll go ahead and graph that left-hand side. And I'm hoping to see 2x intercepts because I came up with 2 answers. And hopefully when I find those 2x intercepts, they're going to be similar to this. So fingers crossed. There's 1. There's 2. Yes! Ooh, and they look like they might be in the right spots too. I'm feeling pretty hopeful about this. I'm doing second calc 0. Little to the left, little to the right. Guess. Nice. Here's that one. I screwed it up. Yep. Yeah. I think we're good. Can anybody think of another way we could use the calculator to check if the solution was right without getting decimals here? We could use second calc value, yeah. And we could just type this in and hope that we get a 0 for our y coordinate. So instead of doing that, if I didn't really care what the decimal value was, I could have typed this in. This might be the better way to do it actually, because it's going to give us the decimal value of it when I hit enter. So remember what I'm doing here. I'm supplying the calculator with an x coordinate. If this is a solution, then the x coordinate of this should be a point that has a y coordinate of 0. It should be an x-intercept, right? So I supply it with that x coordinate. I hit enter. Fingers crossed we get 0 for our y coordinate, and we do. And it converted that to a decimal all at the same time. So that might be the better way to go, actually. All right. That last step is the one I always forget to do. So I'm reminding myself to go back and check for extraneous solutions. We came up with, there are 2 solutions here. Do we need to throw out either of these 2 solutions? The only numbers we would need to throw out would be 0 and -2. Since neither of our solutions are 0 or -2, we did not need to throw them out. So we do not have any extraneous solutions, which we haven't seen yet. I'm guessing they're going to have an extraneous solution on this last one. What do you think? I sure hope so. I haven't done this one in a year. I sure hope so. I'm making myself a mental note to increase the font size on this packet for next year, because I need some space in between these fractions. I'm wondering if x squared plus x minus 6 factors. If it did, it might make our life a little bit easier, especially if the factors matched up with one or both of these. Is it just these 2 things? Yeah? I think it might be x plus 3, x minus 2, so that would be x squared. Here's my -6, and I've got -2x and 3x, which would give me that positive 1x. Yeah, it does factor into that. Well, that's convenient. That's not guaranteed to happen, but it does happen quite a bit. And that's not math, that's psychology. The people who write textbooks oftentimes will have a quadratic that factors into something that appears somewhere else in the problem. Let's think about our excluded values. What values of x are not allowed to go anywhere inside of this equation? -3 would cause problems here and here, right? And 2. So our excluded values are -3 and 2. Now, when you do this on a test, I'm not going to be checking to make sure you wrote the excluded values. But if you include one of those answers in your solution, that's going to lose you some points. So again, my reason for writing this down at the beginning of the problem is in hopes that when I get to the end, I'm not just like, yes, I'm done, and forget to go back and throw those out if they're in our solution, which I've done dozens of times. All right, let's get strategic about what we want to multiply this thing by. X plus 3 and x minus 2 should do it, right? There's one more note that I want to make to myself, and I encourage you to put it in your notes as well. In this step, if you have a minus in between two of these fractions, you need to be super careful with your sign, okay? You're going to see it in your assignment. I wish that I'd put it in this problem. Would you be terribly upset with me if I modify this problem so that it would have this property? It's just a tiny little change. Actually, no, it's not going to help anything. Just make yourself a note. Watch signs if this is negative. If that's a minus, you got to watch your signs. I remember on last year's test, there was a problem looked just like this, and this was a minus, and 3/4 of the class missed the problem because they screwed up the negative sign here. Okay? A moment ago, I told you there's a certain step that I always do, even though it seems like I shouldn't have to. It's because of that. That's the reason why, okay? So let's go ahead and do this. We decided we were going to multiply it by x plus 3 and x minus 2. So let me set this up. I like to write it down because I find it very fulfilling to cancel. I don't know, it just feels so rewarding to be able to go through, and sound effects make it even better. No more fractions. Whoa! All right, and this is the step that I'm going to write down, even though most people probably would say, I'll just skip that step and distribute. I'm going to actually write down what's left, and then I'll distribute in the next step, because if I don't do this and that ends up being a negative, then I tend to make mistakes. Again, I really wish that I'd given you one with a minus. You're going to see it. You're going to see it in your assignment, so you will see it before you see it on the test. Can you guys imagine if that had been a minus instead of a plus, right where my finger is? Imagine if that was a minus. Could you imagine if I had just gone and said, I don't need to write this down again, I'll just distribute. This is just 5x plus 15, right? So in my next step, I might have written down 5x plus 15 and then just brought that minus sign down. What's the problem with that? I would have a minus 5x and a plus 15. Is that correct? No, this is a negative 5. That was a minus. That would be a negative 5. That should be distributed to the 3 as well. So that's where things go wrong, is people start skipping steps, and they say 5 times x plus 3 is 5x plus 15. I'll bring the minus down. Now it's just minus 5x plus 15. That's not what it would be. It would be minus 5x minus 15 if that were a negative. So just watch. Just be super vigilant if you see a minus inside of one of these things, and that step where you're bringing things down and multiplying out. Okay, we didn't have to deal with that though because everything's positive, so all good. What do we got? 2x squared minus 4x, so plus 5x plus 15 equals 25. Oh, this is looking like a quadratic again, guys. Yay! We get to practice our quadratic skills. Yay! 2x squared, what do we got here? That's plus 1x. Minus 25 on both sides gets us minus 10 equals 0. Maybe this one will factor. Spoiler alert, I'm pretty sure it does. So it does factor. At this point, I trust that you guys know how to factor. So just, if you haven't gotten there yet, let's skip over that part of it. You're going to get plenty of practice with factoring in this assignment. It does factor into 2x plus 5 and x minus 2. So now we can use our zero product property, set each of those things equal to 0 and solve. And we're going to get two solutions, x equals 2 and x equals negative 5 over 2. I didn't show my steps to get to those two things. If it makes you feel more comfortable to show the minus 5 on both sides and divided by 2 on both sides, feel free. Yes? You think it's 2x minus 5? No, I don't think so, because if I did FOIL on this, outside times outside would be negative 4x, inside would be positive 5x. We need it to combine to positive 1x. So I need the 5x to be positive. I'm pretty sure. We'll check it here in a minute. All right, are we done? Yes, if we want 7 out of 8 points on this problem on our test. What have I forgotten? Yes?
Why is 5 over 2 negative?
Well, show your steps for solving this.
Okay.
If you're not sure, then go ahead and show your steps for solving this. Do minus 5 on both sides. And then divide everything by 2, and you'll see why that's negative. Yes, good. Thanks for the question. All right, back to my question. Are we done? Nope. How many solutions are there to this equation? There's only one true solution. One of these solutions is extraneous. How do we know that we need to get rid of this x equals 2? Because 2 can't go into that equation. We decided at the very beginning that 2 absolutely could not go into that equation. So it can't be a solution, because a solution is something that goes into an equation and makes the equation true. So our only solution is negative 5 over 2, we think, but we might as well check it. I'm going to show you one other way to check with the calculator. If this is going to be overload for you today, then feel free to ignore it and go back to one of the other 2 ways that I've shown you. But this is a pretty handy thing to know about calculators, so pay attention if you like. What was it? Negative 5 over 2? Okay. Go to your home screen instead of your graph this time. Type in negative 5 over 2. And then stow it into a variable. I always stow into x because x is really easy to get. So the stow button is right down above the on button. If you hit the stow button, it's going to be a little arrow. And then I just use the same x button that we use in our y equals menu. So when I read that, what I'm telling the calculator is take the value negative 5 over 2 and store that into x. And I hit enter. And it's just going to give me a decimal version of what x is now. So now, from now on, anytime I hit x, it's going to say negative 2.5. I can do things like ask it, what's negative x? It's 2.5. Or I could do something like 2x, and it'll give me negative 5. All right, so what I'm going to do then, after I stow it, is I'm going to type in this side of the equation. And then I'm going to type in this side of the equation with the x's, right? There's no need to stick the 2 over 5 in because x is already stored with that value. And if I get the same number on both sides here, then I know that my equation is true. So this is the same way that you were taught to check solutions to equations back in Algebra 1. It's just we're letting the graphing calculator do all the substitution for us. All right, so I'm going to type in 2x over x plus 3. Don't forget your parentheses. Plus 5 over x minus 2. And if you've typed everything in correctly, you should get negative 11.1 repeating. Hopefully, when I type in the other side of that equation, I should get the same thing again. If I did, then I know that I solved this correctly. So 25 divided by x squared plus x minus 6. Fingers crossed. Yes! Check. So using that stow function to store things into variables is pretty awesome. By the way, you can stow values into any letter that you like. So if I wanted to, I could have done my negative 5 over 2 and stowed it into A. I just have to hit alpha A. I like X because I don't have to hit the alpha button every time I pull it up. But there is one problem with X, and I'm going to show it to you guys right now, just in case this comes up later on, so you're not bewildered why something went wrong. Okay, what is stored into X right now? Negative 2.5, right? If I hit X, I get negative 2.5. All right, check this out. I'm going to go to my graph. You don't need to do this, just watch. I'm going to go to my graph, and I'm going to move my cursor around a little bit. And then I'm going to go back to my home screen. What's in X now? What happened? It's not negative 2.5 anymore. Check it out. I'm going to go back to my graph again, and I'm going to move my cursor around a little bit. Watch this number down here where it says x equals. You see it? 4.255. Quitting out of this, going back, I'm going to pull up x again. Do you see what's happening? When you use your graph, the graph uses that variable x. So anytime you go into your graph, it's going to overwrite anything that you stick in for x. Okay, so that's the danger of using x. X is convenient because there's a single button for it. But anytime you do anything in the graph, it's going to overwrite it. So just be aware of that. All right, do y'all have any questions? Okay, well, thanks for your attention.